everyone here has heard of photosynthesis, knows what it does, knows that it's involving plants and sunlight. But what a lot of people don't know is that there's different kinds of photosynthesis that have shown up through different periods of Earth's history. So that's what we're going to talk about here today, and why it didn't all just happen at once. All right, Earth before life. This happened about 4.6 billion years ago. This is a really rough estimate since the dating system is off probably by 10%, which 10% of 4.6 billion is a lot. So with that being said, you can only assume these numbers are really close as we can get. Volcanic eruptions, thunderstorms, nitrogen, carbon dioxide, methane, ammonia, sulfide, nitrogen sulfide, like those are the kinds of things that were found in our environment. Take note, there's no oxygen there yet, so no people, no other oxygen-based life forms existed. So we're going to move ahead to 4.1 billion years in the future, which is 500 years ahead of the time I just mentioned. As the temperature lowered, the water vapor in the air turned into the oceans that we have today. Now, this happened 500,000 years ahead, but that doesn't mean like one day, bam, it just happened. This happened very gradually. A lot of hydrogen escaped into space because we didn't have a sound atmosphere. So 3.5 to 2.7 billion years ago, we get the first sign of photosynthesis, which uses this right here, which is called a proton pump, and this is a part of a cell. That's a very basic cell. And since there's no oxygen to take an electron from, or no water, actually oxygen to take an electron from, it used iron. So this iron was put into the proton pump, and it took a hydrogen ion, which is positively charged, and it runs through that proton pump. Kind of think of it like static electricity. How you rub your feet together, you get a charge. That's kind of what's going on here. The hydrogen pump charges that electron, and you get ATP synthase, which is essentially just energy. People do the same thing. They have the same kind of like ATP inside of them. Not quite the same as a plant, but it's the same concept. So this created an oxidized atmosphere, which allowed for not people, but like other organisms to come about, which we'll see right here. This created a wide diversity in organisms, and it caused a near extinction of other organisms that were intolerant to oxygen, and that we'll see kind of later in the next photosynthesis what happened to the ones that did survive, which is actually, oh yeah. Green algae is responsible for the oxidation of our atmosphere, so whenever you go outside and you see a lake that has a bunch of green algae in it, say thanks, because without that you probably wouldn't be breathing today, or exist for that matter. So 3 to 2.3 billion years ago, we have a more advanced kind of photosynthesis. This uses a reaction center protein, which is very similar to the proton pump, a little more tricky, a little more advanced. What this does is it takes a photon, which is in all life, and it charges an electron that's already inside of the protein center. Now, this follows the transport chain, which is, again, another thing that people have too. This one's a lot more basic than what we have. So we're going to use these little bubbles right here to kind of show the stops that it makes. Each one of these things right here is where it's going to be charged. The electron gets put back into the center of protein, and the hydrogen ion, that same ones before, gets pumped across the membrane and charges the ATP synthase, same one as before. So it's all the same processes, a little different. You can see where the kind of like the evolution idea kind of is coming from this. No oxygen is produced from this. This is called cyclic photosynthesis, by the way, because it goes in a cycle. That electron is just going to be constantly pumped around and charged and reused over and over and over. So it gets sent back to the starting point. Now in cyclic photosynthesis, this is good for low oxygen environments or low light environments, because not a lot of light or oxygen is required for this, especially since no oxygen is produced. So 2.7 to 2.2 billion years ago, we have the calculus, if you will, of photosynthesis. Before, we had the first one, which was like basic math. We had variables put in with the next one, which would be our algebra. And then this one, like I said, is our calculus. That electron that is already there gets charged again, same thing. Photon comes in, raises it up to the charging cell, or charging spot, whatever you want to call it. And that gets put into photosystem 1. Photosystem 1 takes another photon from light, and it goes up to another charging spot. Differences between this one and the previous charging spot is it's going to get passed out and not used again. So cyclic, it goes in a circle. This one kind of goes like a Z shape, and it gets kicked out. The NADPH right here, with a big word, I'm not going to tell you what it is, or I won't get it anyways, I don't need it. This cancels the reaction though, so it doesn't keep building up. It's kind of like whenever you're done eating. Plants don't have stomachs and they can't think, well, I'm tired of eating or I'm tired of making photosynthesis. So whenever a buildup of NADPH comes up, it actually stops this reaction from going on, and some plants will actually switch to cyclic, which is one before it, photosynthesis, and others will just completely stop and wait till they're hungry again. So, how does another electron get put back? It's replaced by breaking down water. So whenever you want to feed your plant water because it's thirsty, it really just needs it to get another electron to do this all over and over and over and over and over again until it can't do it anymore. So, this is most plants that we see today. Trees use this, flowers use this, vegetables, everything pretty much uses this one today. And like I said, it has an off and on switch, which is the NADPH. No other kind of photosynthesis uses this. So, going back, looking at everything, you can see that photosynthesis has taken several steps, each getting more advanced than the last one. And while this is a really seemingly pointless thing to kind of talk about, without it, we wouldn't be here today. So yeah, it isn't the most exciting thing to talk about. People aren't dying because of it. But we wouldn't be here at all if plants didn't start doing this. And we can thank our friend Green Algae for that. So, with that being said, does anybody have any questions?